Hey learners, Jared here, and today we're doing something pretty exciting. I've been wanting to do this for a long time, but I just haven't gotten around to it yet. Because it's about objects going in a circle. So today we're going to be talking about circular motion, and specifically we're going to be talking about uniform circular motion. That is an object going in a circle, but going at a constant speed. Not velocity, but a constant speed. Now, this can be something as simple as a mass being swung at the end of a string, or it can be something as complex as a planet orbiting a star. Now, I know planets don't orbit in perfectly circular paths, but let's just simplify it down to a circular path for this example. So we have a planet orbiting a star. Now, what does it take for that planet to orbit, to actually go around in a circle? Think about the forces that are acting on that planet while it's moving around in that circular path. The only force that could be present is the gravitational force from the star that it is orbiting. And where is that gravitational force always pointing? In towards the center. Now, this might seem counterintuitive to have the force pulling the object in toward the center, because often we hear a centrifugal force or a centrifugal force. That is a force that's pulling out away from the circular path, away from the center of that path. But that is just a fictitious force. That is the force of what it feels like if you are the object that is actually going in a circle. If you've taken a turn in a vehicle, you know what I'm talking about. It's when you turn left and it feels like something is pulling you to the right, or you turn right and it feels like something's pulling you to the left. There is no force pulling you. That is your body just wanting to go straight, to maintain its current path. But in going in a circle, your path has to change direction at every moment. And changing direction goes along with changing your velocity. Any change in velocity has to come from an acceleration. And where there is acceleration, there is force. For an object going in a circle, that force always has to be pointed in towards the center, or a centripetal force. So think about this masking tape going around in a circle. I'm trying to keep its path as uniform as possible, keeping its speed fairly constant. Now, without the force that's acting on the masking tape, then it won't go in that circular path. So think about, what force is it that's keeping it in that circular path? Well, it's not gravity, because that would just pull it down. It's got to be the force from the string, that tension force, because without that tension force, it's no longer going in that circular path. There has to be some force pointed into that center to keep it going in a circle. Every object that's going in a circle needs that centripetal force in. So if I take these magnetic spheres of science and I give them a little spin, do you see how they kind of shrunk up a little bit? My spheres got tighter in, kind of like a pizza dough effect. The faster you spin that pizza dough, the more it's going to stretch out. That elastic force from the pizza dough is what's keeping it going in a circle. Here, the faster they go, the further out they're going to get from that center point, so that, because there's only a limited amount of force that's available here. So if I tighten them up and then I spin them, they widen out. There's not enough force there to get them going in a circle that's that tight, so it spreads out to a bigger circle because there's that much force available. Aw, not enough force for that circle going that fast. Still fun though. Key thing to remember about objects going in a circular path is that the force necessary to keep them in that circular path is pointed towards the center of the circular path. Thank you guys so much for watching. I hope you enjoyed this. As always, keep learning.